talk about this question. So we are given that a gun fires a shell with an initial speed of 500 meter per second and its angle of elevation is given as 30 degrees. The firing is located on a hill 100 meter above a level terrain. The position vector is given, the position function of the shell is given as the question marks is actually, I will rewrite this RT. This is 250 minus 3T I cap plus 100 plus 250t minus 4.9 t square j. So this is how the position vector is given, and we need to find the tangential scalar component of the acceleration at any time t. So for that we must know the formula. The tangential component, let's represent it by at. That's the derivation d over dt of the absolute value or the magnitude of the velocity. So for that, first we need to find the velocity, which is given by r dash t. So r dash t is nothing but dr over dt, dr over dt. So if we differentiate this, this will be 0 minus 3I plus this will be 0 plus 250 minus 9.8 t and j. So this is the velocity function. So the absolute value of the velocity is something in which we are interested, or the magnitude. So that's going to be 3 square plus 250 minus 9.8 t whole square. So that can be rewritten as square root of 9 plus 250 minus 9.8 t square. So this is the absolute value of the value the absolute value of the velocity. Now we need to find the tangential acceleration. So that's going to be the derivative of this function. So the derivative of this function, we're going to use the power chain rule. So that's going to be 1 over 2 9 plus 250 minus 9.8 t square. This complete thing is raised to minus 1 over 2, and then we go inside and we differentiate 9, which is 0. Then we differentiate this function, so 2 comes down, 250 minus 9.8t, and then we go inside and we differentiate this. So differentiation of 250 is 0, and differentiation of negative 9.8t is just negative 9.8. So let's simplify this further. This can be rewritten as 1 over 2 root 9 plus 250 minus 9.8 t square, and that's going to be 0 plus, so we'll not write 0 here. 2 times 250 is 500, and then 9.8 times 2 is going to be negative 19.6, negative 19.6 t, and we already have negative 19.8 outside. So if we simplify this further, we are going to get, let's open up the brackets here. So 19.6 times 9.8 is going to be 192.08 t minus 500 times 9.8. So that's going to be 4900 over 2 times square root of 9 plus 250 minus parentheses 250 minus 9.8 t, and this complete is under a square. So this would be the scalar tangential component of the acceleration at any time t. Thank you.